Welcome to the Crazy Hat Chemist. So today we're doing another video in bonding. So let's get moving. Bam! Today we're doing the drawing of a Lewis dot structure number 8. And we're going to draw the Lewis dot structure for sulfur tetrafluoride. Again, prefix naming, tetra. So you need to know what tetra is for. That is for 4. Unbelievable. So sulfur is a nonmetal, fluorine is a nonmetal, and therefore you got two nonmetals combined together and you have prefix naming. So you're first going to get the formula for sulfur tetrafluoride, and there it is right there, SF4. Now you're going to look on your periodic table and find the number of valence electrons in sulfur, and that is 6. Okay, then you're going to find the valence electrons for fluorine, and that is 7. Going to multiply the number of atoms in each one, and that is 4 fluorines, 1 sulfur, so we don't need to worry about the 1, we just need to worry about the fluorine. Okay, then you're going to sum these two numbers up here after taking the product of them, and then you're going to get 34. You're going to divide this by 2 because I want pairs of electrons, and the number of pairs of electrons in which I have are 17 pairs. Fantastic. All right, now that I have pairs of electrons, now I need to set up my generic setup here. Okay, I'm going to have the sulfur in the middle because it's the least electronegative. Okay, the least electronegative goes in the middle. That is the one element that is furthest from fluorine. Fluorine is the most electronegative element, and it never goes in the middle unless there are just 3 fluorines together. So, obviously, it's the sulfur because it can't be the fluorine. So, the fluorines go around the sulfur like that. Just like in methane, right? CH4, you have that X marks the spot pattern, and that's what we have. Now, the next thing that we're going to do, we're going to take those 17 pairs of electrons and we're going to place pairs of electrons between the central element and the outside elements. And now I have formed a single or a sigma bond. Now, I still have remaining pairs of electrons. I'm going to put those pairs of electrons on the outside of the fluorines, okay, like thus. Okay, and now, how many pairs of electrons do I have yet remaining? I think I have 1 more remaining. So that's going to go dumping right down in the middle of the central element. Okay, and can that happen is the question. Since sulfur is period 3 or greater, that's period 3, 4, 5, 6, or 7, it can exceed the octet rule and be a hypervalent sulfur. Okay, that's why that purple pair of electrons on the central element there is okay, because I have violated the octet rule, but because sulfur is greater than period 3 or greater, then it can exceed that. Okay, now we're going to make sure that the fluorines have an octet, and they most certainly do. Fluorine is one of the few elements that must have an octet at all costs. Okay, now we're going to make this structure look pretty and clean it up, and this is the structure that we finally have here. So we have a lone pair of electrons on that sulfur there and 4 bonding pairs, and then we have the fluorines attached with those bonding pairs. The fluorines have 8 electrons around it, and the sulfur, of course, has 10. Okay, that's a nice cleaned up structure for you. Okay, that is another Crazy Hat video, and here is most certainly a crazy hat. All right. Give me a thumbs up if you like that video, subscribe to my YouTube channel, and I will see you next time for more cool chemistry videos. Bye now.